My name's Ian Clark, and this is my Interactive Advanced Concept Presentation 6 of the nuclear bomb presentation. So I'm going to cover a few things, fusion, fission, the reactions, and then a little graph drawn to kind of explain this whole thing. So first off, a nuclear bomb is a term. So a hydrogen bomb is a fusion bomb, and then an atomic bomb would be a fission bomb. But a hydrogen bomb actually uses a chemical bomb, a fission bomb, and a fusion bomb to create the explosion. And we'll cover all those. First, fusion requires the use of uranium-235 isotope, and neutrons are ejected, and it creates a critical mass, which creates a chain reaction, and then this is how energy is released from that. A hydrogen bomb uses thermonuclear fusion. It fuses atoms together, and it's about 1,000 times more powerful than an atomic bomb, a hydrogen bomb is. And basically, a fusion bomb combines two isotopes of hydrogen, deuterium and tritium, to make helium. These isotopes have extra neutrons in their nuclei, and these two isotopes combine to form helium, and it releases massive amounts of energy very, very quickly, within 100 billionths of a second. And the actual hydrogen bombs use lithium deuteride powder and combine that with tritium, and these two repel each other strongly, so you have to overcome this in some way. And since they only have one proton in their nucleus that made hydrogen a good candidate for fusion, because they only had to overcome that one positive charge. So to do this, you increase the temperature by millions of degrees, which causes them to speed up. This creates a plasma material. The protons and electrons, they can all move freely about, and so this allows the two nuclei of deuteride, the lithium deuteride powder, and tritium to get very close together. This forms a helium nucleus and ejects one neutron. This ejection is where we create energy. The fusion reaction, it heats up. The fission reaction, as I was saying earlier, in a hydrogen bomb is combined. So the fission reaction heats up the plasma to create the fusion reaction with inward pressure. And I have a little graph drawn, we'll go over that. And so, like I say, this is 3 bombs in one. So I'm going to turn the camera around so you can see my graph. Let's see if I can. So it may be difficult to see here. So this would be the warhead of a hydrogen bomb, and in it at the top we have a fission cell in the center that's surrounded by a chemical bomb, and below that you have your fusion cell. So the chemical bomb is detonated first, which causes the fission cell to implode on itself, and this creates a critical mass chain reaction of neutrons when the atoms split. So it continually creates more neutrons, ejects them out. This is where we have the chain reaction. The center section of this is all styrofoam, so the fusion cell, the chain reaction heats up the styrofoam, and it makes this plasma around the fusion cell cylinder. And this happens, but you have high energy gamma rays and X-rays pushing down on, creating an inward force on the fusion cell. And this plasma mixed with this inward force, it creates a positive feedback loop of fusion and fission reactions. So in the fusion cell, like I say, you have lithium deuteride and a neutron, which makes helium and tritium. And so tritium and deuterium, that the final outcome of the energy that's created is helium, a neutron is ejected, and energy. And this happens in about 600 billionths of a second, and it's mass being converted to energy. So the formula to understand that would be Einstein's E equals mc squared. So this is my basic explanation of a complicated process of creating a hydrogen bomb.